Welcome to our YouTube channel Maths Point. In our last video tutorial, we read about the angles formed by transversal with two lines, and we came across different pairs of angles that are formed by the transversal with two lines. And there we saw two groups. The first one among them was angles formed on the same side of transversal, which includes the first one as corresponding angles. And we said the corresponding angles are those angles which are formed on the same side of transversal with different vertices and one lying in the interior and another in the exterior. So we have the different pairs as angle 1, angle 5, then angle 4, angle 8. These are on the left side of this transversal, and then on the right side we have angle 2, angle 6, and angle 3, angle 7. So these are our four pairs of corresponding angles. The another pair that we saw was co-interior angles. These are again lying on the same side of transversal with different vertices and both lying in the interior. So we have angle 4, angle 5, and on the other side it's angle 3, angle 6. And one more pair that we saw, that was co-exterior angles. It's again lying on the same side of the transversal with different vertices, but this time both lying in the exterior. So we are having the two pairs as angle 1, angle 8, and on the other side it is angle 2, angle 7. So these are different pairs of angles that lie on the same side of transversal. Then we said there are other pairs of angles that lie on the alternate sides of the transversal, and we got them here as alternate interior angles, which are angles lying on the different sides of the transversal with different vertices and both lie in the interior. So we have angle 4, angle 6, angle 3, angle 5. So angle 4, angle 6, and angle 3, angle 5. Then we read about one more pair, and that is alternate exterior angles. That means again angles lying on the alternate sides with different vertices, but this time both the angles are lying in the exterior. So we have angle 1, angle 7, and angle 2, angle 8. So these are the different pairs of angles that are formed by the transversal with two lines. So we came across all these different pairs in our last tutorial. Now, in our today's tutorial, we'll be talking about the properties of these pairs of angles formed by transversal with parallel lines. That means this time we'll be having the parallel lines. So the first pair of angles is corresponding angles, and the property related to corresponding angles is given in the form of an axiom which states that if a transversal intersects two parallel lines, then each pair of corresponding angles are equal. So we are having here two lines, line L, line M, which are parallel to each other. So we consider that L is parallel to M and N is transversal. So the corresponding angle axiom says if a transversal intersects two parallel lines, then each pair of corresponding angles are equal. If we will name the angles here as 1, 2, 3, 4, 5, 6, 7, 8. Then, according to this statement, we can say that angle 1 is equal to angle 5, angle 2 is equal to angle 6. Similarly, angle 4 is equal to angle 8, and angle 3 is equal to angle 7. So it says that each pair of corresponding angles are equal. And then we have its converse, which says if transversal intersects two lines such that each pair of corresponding angles are equal, then the lines are parallel. That means in the converse of the first statement, if it is given that corresponding angles are equal when intersect when transversal intersects two lines such that corresponding angles are equal, then the lines will be parallel. So this was the property of corresponding angles formed by transversal with parallel lines. Now we will see the property of other pairs of angles also, but those properties are in the form of theorems. So the first theorem goes as if a transversal intersects two parallel lines, then each pair of alternate interior angles are equal. So this time let's consider angle 1, angle 2 as alternate interior angles. Similarly, we will consider another pair of alternate interior angles as angle 3 and angle 4. So the statement says here that if a transversal intersects two parallel lines, that means L is parallel to M and N is transversal. Also, it's given that angle 1, angle 2 and angle 3, angle 4 are alternate interior angles. Now we have to prove that these alternate interior angles are equal. So we have to prove angle 1 is equal to angle 2, and we also have to prove that angle 3 is equal to angle 4. Let us prove it. We know that when transversal intersects these two parallel lines, then corresponding angles are equal. Let's consider this as 5. So we have here, since N is parallel to M and N is transversal, so by using the corresponding angle axiom, we can simply say that angle 4 is equal to angle 5 because corresponding angle axiom. Also, we can say that angle 5 is equal to angle 3 because they are vertically opposite angles. And we have proved it in our previous tutorial that vertically opposite angles are equal. So from first and second, we can say that angle 4 is equal to angle 3, and this was one of the pairs of alternate interior angles which we have to prove that they are equal. So we proved that angle 3 is equal to angle 4. Similarly, we can take here one more angle as angle 6, and we can say that angle 6 is equal to angle 2, then angle 6 is equal to angle 1, because they are vertically opposite angles, then from these two we can directly say that angle 1 is equal to angle 2. So this is another pair which we have to prove. So we can similarly say angle 1 is equal to angle 2. This we proved here that alternate interior angles are equal. So hence proved. So we can simply say that when transversal intersects two parallel lines, then each pair of alternate interior angles are equal. Now we have the converse of this statement, and it says if a transversal intersects two lines such that each pair of alternate interior angles are equal, that means this time we are having, it is given that angle 1 is equal to angle 2. It's given that L and M are lines and N is transversal such that angle 1 is equal to angle 2 and angle 3 is equal to angle 4. As it is given, each pair of alternate interior angles is equal. Now we have to prove that the lines are parallel. We have to prove that L is parallel to M. Now, in order to prove this statement, we are having one of the axioms given as corresponding angle axiom, which says if transversal intersects two lines such that corresponding angles are equal, then the lines are parallel. So we will simply prove here that corresponding angles are equal, then we can directly say that the lines are parallel. Let's consider here it as angle 5. Now we can say L and M are lines and N is transversal such that angle 1, or we can say such that angle 3 is equal to angle 4. Let's consider this as first. It is given. Now we know here that angle 3 is equal to angle 5 is equal to angle 5. Consider this as second because vertically opposite angles. So from first and second we can say angle 4 is equal to angle 5. And if we will see this pair of angles, angle 4 and angle 5, these are corresponding angles, and corresponding angle axiom says that if transversal intersects two lines, this by the corresponding angle axiom, by corresponding angle axiom, which says if transversal intersects two lines such that corresponding angles are equal, then lines are parallel. So we got here that corresponding angles are equal, then we can say by corresponding angle axiom, L is parallel to M. So we proved that if transversal intersects two lines such that each pair of alternate interior angles are equal, then the lines are parallel. So we proved these two statements. Now we have one more statement that is related to co-interior angles, and it's again in the form of a theorem, which says if a transversal intersects two parallel lines such that each pair of co-interior angles is, then each pair of co-interior angles is supplementary. That means this time we have to prove that co-interior angles are supplementary. So it means we have to prove angle 1 plus angle 2 is 180. Similarly, we have to prove that angle 3 plus angle 4 is 180. So we are given that L is parallel to M and N is transversal. Also, we mentioned it in the figure that angle 1, angle 2 is one of the pairs of co-interior angles, and angle 3, angle 4 is another pair of co-interior angles. So angle 1, angle 2 and angle 3, angle 4 are co-interior angles. Now we have to prove that these co-interior angles are supplementary. So for that we have to prove angle 1 plus angle 2 is equal to 180 degrees and angle 3 plus angle 4 is equal to 180 degrees. Now let's prove it. We know that from our last statement that if transversal intersects two parallel lines, then alternate interior angles are equal. So since L is parallel to M and N is transversal, therefore angle 1 is equal to angle 4. Also, here we can simply say angle 1 plus angle 3, they are forming the linear pair of angles. So by the linear pair axiom we can say their sum is equal to 180 degrees. So instead of angle 1 we can write angle 4. So it is angle 1 plus angle 3 180. Instead of angle 1 we can write angle 4 plus angle 3 is equal to 180 degrees. So we proved that the co-interior angles are supplementary. Similarly, if we will write instead of angle 4 as angle 1, similarly we can take here angle 4 plus angle 2 is equal to 180. Then we will replace angle 4 by angle 1. Then we can prove that angle 1 is equal to angle 1 plus angle 2 is equal to 180. Similarly, angle 1 plus angle 2 is equal to 180 degrees. Thus we proved that the co-interior angles are supplementary. Now we have one more statement that's again in the form of a theorem which says, and it is the converse of our previous theorem, and it says if a transversal intersects two lines such that each pair of co-interior angles are supplementary, that means this time it is given angle 1 plus angle 2 is 180. Similarly, angle 3 plus angle 4 is 180. Now we have to prove that the lines are parallel. So it is given L and M are lines and N is transversal such that angle 1 plus angle 2 is 180 degrees and angle 3 plus angle 4 is 180 degrees. Now we have to prove that L is parallel to M. Now let's prove it. Again, we can use the two results that we already got. If we are able to prove that the corresponding angles are equal, then we can say lines are parallel. Similarly, if we are able to prove that alternate interior angles are equal, then we can say the lines are parallel. So now here we can simply say angle 1 plus angle 3 is 180 because they are linear pair of angles. So linear pair axiom. Also, angle 1 plus angle 2 is equal to 180 degrees, and it is given. Since in both of these equations the sum of the two angles is 180 degree, so we can simply say from first and second we get angle 1 plus angle 3 is equal to angle 1 plus angle 2. So we are having angle 1 on both the sides. We can simply cancel out these. So we will get angle 3 is equal to angle 2. And if we will see in our figure, they are alternate interior angles. Which are alternate interior angles. And we read in our one of the previous statements, if transversal intersects with two lines and if alternate interior angles are equal, then the lines are parallel, which are alternate interior angles formed by transversal N with lines L and M. Thus we can say line L is parallel to M. Hence, proved. Thus we proved that if transversal intersects two lines such that each pair of co-interior angles are supplementary, then the two lines are parallel. So we saw different statements or different properties related to angles formed by transversal with two parallel lines. I hope you understood these properties. Thank you.